It says I have an hour and 19 minutes. That's just enough time to get through this, right? Okay. So, yeah, because my talk is an hour and 20. Go figure. And tonight we're doing continuous environmental tracking. Let me go to, make sure this is the right version. 524, that's it. Continuous environmental tracking. F5 to launch. Here we go. We got the, now I got to bring it back down. What's going on with that? Okay, hang on a second. We will get this here. Close enough. All right. Continuous environmental tracking, a Bible-based alternative to natural selection. Understanding how organisms adapt to their environments in order for them to fulfill the mandate to be fruitful and multiply and fill the earth. Now, where have we read that before, right? Now, for simplification, I may refer to it as CET. CET is not to be confused with CRT. That's another thing that's going on in the culture and everything like that. So, CET. Instead of constantly exposing the flaws regarding Darwin's theory of evolution, of which there are many, CET, Continuous Environmental Tracking, provides a tool or framework for research that allows Bible-believing scientists and laypersons, you don't have to have a background in engineering or in medicine or biology, to go on offense. And that doesn't mean being offensive. It means we can take the argument to the community. We don't have to wait for them to challenge us. We can say, hey, by the way, to make a much stronger and sounder case for discovering and understanding the truth about how all living things adapt to their environment. Now, does that sound like a good idea? Yep. Okay, so let's start by asking this question. Can employing engineering principles to the study and analysis of living organisms and their ability to adapt to environmental changes provide a better explanation for those changes than the use of the term natural selection? Now, in short, the answer is yes. Otherwise, why would I have put this together, right? So basically what we're going to do is we're going to be studying different organisms. I'd say critters, but I'm going to use the word organisms for now, from an engineering perspective. We're going to go into looking at biology as if we were engineers and say, how is this thing engineered? Okay? Now, don't worry. Like I say, you don't have to have an engineering degree. I would say that fourth graders should be able to hang on to just about all of what we have to say tonight. Okay? You don't have to have the nuances. If you get the general picture of where we're going with this, you'll be able to see that, you know what, this is really easier to understand than you might think at first blush. But we just have to examine a few aspects of some basic engineering principles, and away we go. But first of all, audio video check. I got one or two video clips, and you know what? You've probably seen this one before. It's the documentary for Is Genesis History. And why are we not getting audio? Oh, I bet you I know why. While that's playing, just excuse me for a second here. I have to tell the computer where to send the output. Because when you're using HDMI, it defaults to the HDMI output. And come on. All right, so now sound. Oh, now I don't want it to say this. Oh. Power always helps. Man, this really did seem like a good day when it started off, you know? Here we go. All right, audio video check. And launch from this page. And oh. I went too far. Okay, here we go. Now it'll do it. Okay.
There are many questions about the history of the Earth. What major events might have occurred to shape it? Was there a global flood? A Big Bang? How did the Earth become filled with so many amazing and diverse creatures? I'm Del Tackett, the creator of the Truth Project, and I've spent a year asking a wide variety of scientists to help me better understand the world we see around us.
Well, it was a story that we all learned in grammar school. Colorado River, over tens of millions of years, cut the Grand Canyon. Most geologists have jettisoned that idea. You can't imagine a canyon enduring that long with erosion. Time is not a magic wand that solves all the geologic problems of the world.
The past is the key to the present. I want to understand why the way the world is today. You've got to understand what happened in the past.
Been there.
You take the present processes and extend it into the past, not unreasonable, but there's evidence in the rocks themselves that you can't do that.
If the fossils of dinosaurs have been dated incorrectly, then it's very likely the fossils of any organism have been dated incorrectly, and therefore then the geologic ages themselves are incorrect.
I believe in change over time, but I'm not an evolutionist. The shark has the ability to change, to adapt, to respond dynamically to the environment. But they're still sharks. And when we look at the fossil record, they're still sharks.
We've been told to look at a history of the Earth that is millions and billions of years old. Is there evidence that it could have been created in only a matter of days?
You really need to begin by looking at the governing paradigm about the history of life and the history of the universe.
We've got two possibilities, and all the natural history museums in the country all give you just one of those views.
Is there a recorded history that shows us a different view?
And when we look at the fossil record, we can see that complexity is all there from the beginning, and this begs the question of where did all this complexity come from?
An ancient history recorded in the book of Genesis.
You have this notion that there is providence that is then worked out across time in a linear, understandable, traceable fashion.
We'll come face to face with an earth-shattering question. Is Genesis history?
How many of you have seen this documentary so far? A few. I'm in the process of, I just recently ordered a public viewing license so I can show it for an audience up to 75 people. So at some point in time, we're going to have that as our presentation, because here you got, because in the video, it may be a video, you say, yeah, video, come on, I can watch a video at home. Well, yeah, well, you can't watch a video where you have like 9 or 10 PhD scientists who are all awesome Bible-believing creationists, and one after another give their evidence, lay it all out very succinctly. So we're going to work on that. And then I'll also be purchasing more copies available for people to have at home. All right, how many of you recognize this face? One or two people, okay. This is Dr. Randy Galuza. He's the president of the Institute for Creation Research. This is their brand new logo that they just came out with recently. Dr. Galuza has authored several books and contributed to many others. He appears in several DVDs. Back in July of 2016, way back when, Dr. Galuza began to propose a model for Bible-believing scientists, and anybody else too for that matter, to guide biological research based on engineering principles. And it stemmed from a particular question that he asked, but let's look at his credentials really quickly. He has a Bachelor of Science in Engineering from the South Dakota School of Mines and Technology, a Bachelor of Arts in Theology from Moody Bible Institute, a MD from the University of Minnesota, and a Master of Public Health from Harvard. Okay, so he's no dummy. He served 9 years in the Navy Civil Engineer Corps and is a registered professional engineer. In 2008, he retired as a lieutenant colonel from the Air Force, where he served as 28th Bomb Wing Flight Surgeon and Chief of Aerospace Medicine. He then joined ICR as National Representative and was appointed as ICR President in 2020. Okay, so he has his first degree was in engineering. Then he gets into medicine, and so he's got this engineering technical sort of background. And as he studies medicine, he says, you know what? These things all look like they're designed. Why are we supposed to believe that they just kind of happened? Okay, and I said, talking about taking this on offense means that we can go out there and we can say, look, this makes so much more sense from an engineering perspective rather than a piece-by-piece random put-together type of process. So here is a basic question that launched this whole thing. Have living things been engineered for life, or is all life just a cosmic, biological, against all odds accident? And when we say against all odds, mathematically, it really is against all odds. Okay? Now, Dr. Galuza, for several years, has advanced the notion that the term natural selection is a misnomer and really shouldn't be used, okay? Now, I have to say, at the same time, that there are several young earth creationists, Bible-believing Christians, that disagree with him on this point. Some of it is to say that, well, if we throw that out, then it's going to cause confusion because there's so many people who are used to understanding natural selection, and it might make the argument hard to understand. And Dr. Galuza says, no, let's go for the jugular on this. Let's expose how natural selection. Why? Because nature doesn't select. Okay. Now, we're not here to get into that argument because these are all the people who disagree with him on this point are well respected, and they have they make a point. Okay, but not every creationist agrees on every point, and in this particular case, not to get caught up arguing semantics. Okay, which is really kind of what it gets down to. But we have to. What we're going to look at tonight is the question: does nature select? Can nature select? Instead, Dr. Galuza prefers the term engineered biology. Now, why does Dr. Galuza say this? Well, because when we look at organisms and their environment and how they adapt, you have the organism and you have the environment, and at where these two meet, okay, the interface is at the organism. The organism is what does the adapting. Okay, nature or the environment does not force the organism to adapt. The organism senses the environment and makes its own adaptations. With me so far on that? Okay. Nature doesn't say, "Hey, I'm going to make you have to do something," and the critter or the plant says, "Oh, okay, I'll do it." Whatever. So to put it another way, nature does not affect the organism. The nature provides the surroundings, but the organism responds from what it detects. So to illustrate that, we're going to put a little radar antenna up there, right? Marked CET, Continuous Environmental Tracking. So this radar antenna here helps us see that it is the organism that is tracking the environment. It's looking for changes in the environment and determining a response to what it senses. Now, to better understand this whole concept of natural selection, let's back up just a little bit to Darwin's book on the Origin of Species by Natural Selection. The complete title, if you look carefully, is By Means of Natural Selection, and then the second title, which is, come on, The Preservation of Favored Races in the Struggle for Life. Now, I could take a whole hour describing Darwin's racist views in this book and in some other ones too, okay? And, but really quickly, to go to his book, Origin of Species, in chapter 4, it reads this way. It may be metaphorically said that natural selection is daily and hourly scrutinizing throughout the world every variation, even the slightest, rejecting that which is bad, preserving and adding up that which is good, silently and incessantly working whenever and wherever opportunity offers at the improvement of every organic being. This was Darwin's philosophy. He didn't observe this. This is a conclusion he came up with. But look at the action verbs that Charlie is using in this imaginary world of his. He says that nature is scrutinizing, nature is rejecting, nature is preserving, nature is adding up, nature is incessantly working. He is attributing nature with volition. What is volition? Volition is the ability to make a choice. Okay? Does this remind you of a scripture, such as, say, Romans 1:25? For they exchanged the truth of God for a lie and worshiped and served the creature rather than the Creator, who is blessed forever. Amen. That's from the New American Standard Bible. The New English translation reads this way. They exchanged the truth of God for a lie and worshiped and served the creation rather than the Creator, who is blessed forever. It must be noted, first and foremost, that Darwin knew essentially nothing about the cell or about genetics. The discovery of DNA came 93 years after On the Origin of Species was published and 71 years after his death. Now, Darwin believed that the cell was just a little blob of protoplasm that just kind of kept things together. He didn't realize that it's an entire city of operations going on inside there all the time. So, what did Charlie have to say about how natural selection acts on organisms? He said this, quoting again, Natural selection acts only by taking advantage of slight successive variations. She can never take a great and sudden leap, but must advance by short and sure, though slow steps. In other words, there's no such thing as a quantum evolutionary thing. It's like, it's all got to be very, very tiny, and little by little by little by little. And each one of those little steps has to give the organism a survival advantage. And and we could spend 45 minutes just talking about example after example of how that wouldn't work. Okay, a reptile turning into a bird is going to have a really, really, really bad leg before it ever has a very, very, very usable wing. Okay, and it'll be eaten by a predator. Okay, so backing up just a few pages before this, he says, if it could be demonstrated that any complex organ existed which could not possibly have been formed by, please notice, numerous successive slight modifications, my theory would absolutely break down. This is what's known as a falsification test. And say, in science, you create, you do your testing, your analysis, you come up with a hypothesis, and then you try to see if you can falsify it. If it withstands all the falsification tests, then it moves on from a hypothesis to a theory, and then eventually, if it continues to be proven correct every time, then you can have a scientific law. Okay, so Darwin's theory of there has to be a lot of them. They have to be successive, they can't be regressive, and they have to be very slight. Now we're going to be looking at this aspect again later in this presentation. Did Charles Darwin have any doubts or uncertainties about his theory? You wouldn't know it from the way, evolutionists talk about today, but he says on page 155 in his book, to suppose that the eye, with all of its inimitable contrivances for adjusting the focus to different distances, for admitting different amounts of light, and for the correction of spherical and chromatic aberration, could have been formed by natural selection seems, I freely confess, absurd in the highest degree. Well, yeah, he calls it absurd, and we should agree. I mean, it sounds like he's describing a Nikon camera here, with all the different apertures and f-stops and everything else. Chapter 4 On the Origin of the Species is entitled Natural Selection. In it, Darwin makes several allusions to human breeders breeding for specific traits in pigeons and other animals, and he uses this to extrapolate to all of life. He had no observational data to support this idea of unbounded extrapolations. Okay? If a bird can adapt its beak to eat bigger and bigger seeds, then over how many millions of years it can turn into a Galapagos elephant or something, right? Basically, Darwin believed that given enough time, pond scum could become a public speaker. And I don't buy that. So here is the deal.
I've heard some, but I can't think that's
Yeah. Darwin attributed characteristics of volition upon nature that nature, in quotes, simply does not possess. His comparison to human breeders selecting for desired traits is faulty in that making an abstract comparison to human volition does not endow nature with that fact. In other words, just because you say it doesn't make it so. Okay? And we just have to look at what some politicians are saying today about things and say, oh, it doesn't make it so. But we won't go into politics today. Okay. So, but you get the idea. If people just think, well, if we just keep saying it, like, okay, for instance, let me go out on the edge here. It's Putin's fault. Yeah, and that explains everything, right? And that makes no, okay. So then, how does the model of continuous environmental tracking better explain the ability of organisms, to adapt? Well, we have to go back to God's original mandate. And what was that? We find it in Genesis 1:22. And God blessed them, saying, be fruitful and multiply and fill the waters in the seas and let fowl multiply in the earth. That's referring to the birds and the fishies. Then in verse 28, then God blessed them, and God said to them, be fruitful and multiply, fill the earth and subdue it, have dominion over the fish of the sea, over the birds of the air, and over every living thing that moves on the earth. And then to Noah, after the flood, okay, in Genesis 8, verse 17, he says to Noah, bring out with you every living thing of all flesh that is with you, birds and cattle, and every creeping thing that creeps on the earth, so that they may abound in the earth and be fruitful and multiply on the earth. Now, we can see that God had in mind, his plan was for the creatures that he brought to Noah and had him save in the ark, that they would be fruitful and multiply and fill the earth, okay? They would spread out. At the same time, we know, without having a PhD in biology, from our own observation and from common sense that not every organism is suited to live in every single place on the planet, right? Personally, I am not suited to live in Antarctica. And that's okay, because you know why? I don't think emperor penguins are suited to live in Heber Overgaard, because there's just not enough fish and it's not cold enough and stuff like that. Okay, so we understand. He says to fill the earth, but it doesn't mean that every creature is able to live everywhere. So, we can say that not all creatures detect and or respond to the same stimulus in the same way. Let me give you a real easy example here. Let's suppose you're somewhere out in Arizona and you see a man walking his dog, and somebody nearby, we'll just say it's a prankster teenager, has a dog whistle, and he blows the dog whistle. Why does only the dog respond? Okay. Well, we'd say, well, the dog responds because he can hear the sounds at the frequency that the dog whistle makes, okay? Well, the man is exposed to the same environment, but he's not detecting it, right? His sensors are not capable of detecting that, so he's not going to respond. Now, he's going to be responding by suddenly being tugged at the end of the leash, okay? But that's a little different. So two creatures can be exposed to identical situation, but they would respond differently based upon their sensors and based upon their programming on how to respond. So it's an organism's traits. It's the traits that they have, not its exposures, that determine their response. Now, the same is true for design success or design failure in the biological world. Not every creature is designed to survive in every environment. So that brings us to another question then. If it was God's plan for critters to adapt, then would not he also have given them the ability to adapt to the different environments, ecosystems that they would encounter in the post-flood worlds? Okay, we don't believe God just says, okay, you're off the ark, good luck, have fun with that, you know. No, God is going to equip his creatures with the ability to adapt to fulfill the mandate that he had in mind. Does this seem reasonable or unreasonable? I'm assuming because you took the trouble to come out here tonight to learn about this, that you're thinking, yeah, okay, it's very reasonable. All right. I want to replay really quickly that short little clip of Dr. Robert Carter from the movie Is Genesis History. I had a chance to meet with Dr. Robert Carter last Friday evening, chatted with him. I says, any chance we can get you to come here to Arizona to speak? And he says, well, the Creation Ministries International, of whom he's representative with, they had speakers, dates all lined up during COVID. And then COVID came, they had to cancel all those. He says, so when things open back up, that backlog just, whoom, fill up really fast. So he says, might be another, probably another year and a half or 2 years before he can make it back out. I said, don't worry, when you're ready, we'll be ready for you. So, but he's talking about sharks, and I love this little remark that he says here.
I believe in change over time, but I'm not an evolutionist. The shark has the ability to change, to adapt, to respond dynamically to the environment. But they're still sharks. And when we look at the fossil record, they're still sharks.
I love that line. They have the ability to adapt and respond to their environment, but they're still sharks, right? They don't change in anything else, but they do adapt to their environment. Let's get back to Romans 1, verse 20. We all know this one. For since the creation of the world, God's invisible attributes, which are his eternal power and divine nature, have been clearly seen, being understood from, catch this phrase, from what has been made, so that people are without excuse. Now this expression, what has been made, shows up in the Greek New Testament one other time. It's found in Ephesians 2, verse 10, where he says, we are his workmanship, created in Christ Jesus for good works, which God prepared beforehand so that we would walk in them. The idea of workmanship instinctively denotes a workman. A workman is somebody who crafts something, okay? So what Romans 1:20 is telling us is that from God's craftsmanship, from what he has crafted or made, everybody is without excuse. God's workmanship is clearly seen. By whom? By everyone. So in other words, no one on this planet has any excuse for not seeing God's workmanship. You can go around, nope, everything just got here by itself. Okay, you can do that to yourself if you want to fool yourself. But anybody who says that they don't see God's workmanship in the thing of nature is not being honest, and they're not then giving him the praise that he's due. Now, getting back to Dr. Gluza, he writes, human engineers know they must build dynamic machines to relate to dynamic environments. If human engineers can use a tracking system to detect and maintain the surveillance of, say, a moving target, could creatures employ a similar overall strategy that utilizes different types of mechanisms to track changing conditions? You know, if we can build things to track, okay, then why is it unreasonable to think that God couldn't have done the same thing and installed it in creatures? The essential well-matched elements underlying the self-adjustable property of tracking systems are these. 1. Input sensors to gather data on external conditions. 2. Internal programming that specifies reference values and logic segments that compare input data to a reference and then select a suitable response. And 3. Output actuators to execute those responses. Now, this might sound kind of technical right now. You're like, what? Trust me, this is all we're going to go over this again and again and again until it becomes really super clear. The route from condition to adaptation runs through these components, and the removal of any one stops self-adjustment. You take on any one of these, 1, 2, or 3, creature's not going to adapt. Research demonstrates that organisms have these same elements and utilize them to track changing conditions and produce specific results. So again, the 3 elements that organisms need to adapt are 1, input sensors to detect the change in the environment. Then they need 2, an internal program or a logic circuit, if you will, to compare that input data to reference values and select a suitable response. And then you need output actuators to execute specific responses. Now, here's a great Arizona example. You go outside, and you're out there working in the sun, and you know how to do it. Before you go outside, you say, oh yeah, okay, I have to wear a hat because it's going to be sunny, and a t-shirt, and you're working out your yards, and then the sun starts slowly sinking, and all of a sudden you're like, oh, I'm getting a little chilly, okay? As your recognition of chilly is because why? Your body has temperature sensors. You're saying, oh, it's getting colder now. And so then you're deciding, well, what do I do? Do I put on a sweater? Or do I just knock off for the day and go inside? Okay, that's your output actuators. So you sense the change in the environment, you come into a decision, you say, oh, yeah, it's getting colder, or whatever, or it's getting darker, maybe I should take my sunglasses off now so I can see better. And then your output actuator is the action that's initiated. Okay, that's really simple. We do that, we don't even think about it. It's just kind of a subconscious thing. The engineering principles that underlie how human design things self-adjust to changing environments is the most expedient way to explain how organisms adapt. So, keeping these 3 things in mind, input sensors to make the detection, internal programming, and output actuators. Now, I want you to watch this short video. It was produced many, many years ago by Subaru. And then afterwards, I'm going to ask you a question, okay?
It is through 50 years of daring that we have been able to offer drivers peace of mind. 50 years of designing cars for crash survival that led us to our most revolutionary feature yet. A car that can see trouble and stop itself to avoid it.
Now imagine you were an engineer working for Subaru, and you were talking about this situation, and somebody, a friend of yours, says, I know how you came up with this. It was take your kid to work day, and you brought your teenage son to work, and then you got called into a little staff meeting, and you wanted to keep your son busy, so you took him into this warehouse, this little store, and you said, you took a cardboard box with a bunch of electronic parts, and you dumped on a workbench, and you plugged in a soldering iron and said, here, solder these things together, keep yourself busy. And you went to your meeting, and you came back an hour later, and Dad says, hey, Dad, look what I did. And you said, wow, that's amazing. You put together a self-actuated braking system. If you were the Subaru engineer, and somebody tried to tell you that, you'd be saying, you're crazy. I'm insulted, right? You wouldn't say that something as complicated as a car's self-braking system could just randomly happen through random processes, right? It would be insulting. Well, if we can recognize design in a situation like that, is it not reasonable to say, let's take that same sort of engineering sensibility and look at biological organisms and see if they have complex integrated systems? And what did that car have to have? It has to have a sensor to detect that this wall was coming up on it. It had to have a logic circuit to compare those values, and then the output actuator was what? Hit the brakes. Input sensors to detect the obstacle, to analyze distance and velocity, determine the exact time to apply the brakes, and the output actuators to execute the sequence. So, Dr. Gluza continues. If the design-based model of adaptation, postulating that organisms continuously track environmental changes, is correct, it would emphasize organisms as active, problem-solving entities, not passive modeling clay. It's a creature's self-adjusting innate mechanisms that produce change-suitable solutions that precede the changing conditions rather than being caused by them. In other words, it can make this because it was designed ahead of time to anticipate this kind of environmental thing that it's going to deal with. Could it be possible that creatures actively track changing conditions rather than being passively pressured by them? Well, again, the fact that we have this presentation means, yeah, that's where we're leading. All right, so Darwin basically imagined critters like modeling clay. And nature selects, right? The nature will force this organism to adapt and change somehow. We're going to reject this and proceed under the premise that instead the organism tracks its environment and adapts accordingly. Now, to do that, it needs what? What are the three components? You're all in your brain, you're remembering, oh yeah, input sensors, got to have those. Second thing is we got to have internal programming. And the third thing is we have to have output actuators to direct those functional changes. It is an entity's traits, remember, not its exposures that determine design success or failure. Engineered solutions to problems must precede the problem. The existence of a solution is not because of the problem or due to the problem. Now, I stated earlier that continuous environmental tracking proposes that the system needs to be designed ahead of time. Okay? I stated that we should employ engineering principles to guide the research. Okay? Now, before we go into this, let's look at a few creatures that are very unusual and unique. Who remembers this? If you're about my age, faster than a speeding bullet, more powerful than a locomotive, and able to leap tall buildings in a single bound. And you all say, oh yeah, man, I remember Superman. Okay. Well, I'm talking about a different fellow. I'm going to talk to you about a fellow who can survive in space without oxygen. He can survive exposure to radiation 1,000 times greater than Earth's surface, can withstand pressures 6 times greater than the deepest spot in the ocean, can be dehydrated for over a century and return to normal activity when exposed to water. I gave this talk last weekend, weekend before last, in Sholo, and by this point there was a girl in the audience and she had her hand go up in the air, and I'm just like, I think she knows. I just knew that she knew because of the enthusiasm with which she was raising her hand. Can persist in nearly boiling water and at temperatures approaching absolute zero. Anybody want to make a guess what this creature is called? It is known as, drum roll please, a tardigrade. Tardigrade. This is a tardigrade seen by an electron microscope. It also goes by the name moss piglet or water bear, okay? What the few biologists who study them have discovered, however, is that the secret of their survival is the ability to shut down their metabolism completely while maintaining their cellular structure. They have the ability to switch off all living processes and start them up again. The biggest adults may reach a body length of 1.5 millimeters, the smallest below 1/10 of a millimeter. Newly hatched tardigrades may be smaller than 0.05 of a millimeter, and a typical dust mite measures 0.2 to 0.3 millimeters in length. Okay. Now, the question is this. How would this tiny creature have been able to survive all those hostile environments unless it had been previously designed to do so? Okay. Did an early evolutionary ancestor find itself in one of those spots, say, ooh, I have to adapt, and it figured out a way to adapt? And then it's like, oh, now I'm in this other environment. Now I got to figure out another way to adapt. Oh, now I'm over here. Now I got to find another way to. You right away you say that's just absolutely silly. Okay. So this creature, in order to survive all those varying different types of hostile environments that none of us would want to go into, right? It had to have been designed from the get-go to survive in those environments. Now, if natural selection and survival of the fittest were truly valid scientific theories, then why don't tardigrades rule the universe? If they can survive so well everywhere, right? They can survive in places that we can't even think of for 2 seconds or a half a second. So if they haven't evolved, then let's rephrase this question. Did nature select for this critter to survive, or did it already possess the innate ability to survive? Okay. Now, tardigrades are rather interesting. They are actually becoming kind of a interesting phenomena in our culture. Okay. Anybody followers of Marvel Cinematic Universe? They had Ant-Man, and then they had the Ant-Man and the Wasp, the sequel. Okay. And in the sequel, Ant-Man and the Wasp, there was a scene where Hank Pym, who was played by Michael Douglas, he enters the quantum realm where he shrinks down into molecular size. And while he's down there, he encounters tardigrades. And they go swimming towards him and stuff like this, you know, whatever. But he escapes the last possible second from being devoured. But it's interesting because as I was researching this, I found out that tardigrades are so popular that you can go to a website and buy a tardigrade plush toy. They're called Budsies, and you can buy them, and it's like, you know, and when I showed this last time, a lady in the audience said, "Oh, it's cute." And I said, well, cute or disgusting, depending on how you want to look at it. But it's like, so yeah, tardigrades are becoming like the kind of a vogue sort of a thing out there. Not really sure why, but anyway, I thought I should throw that in just to show you that, you know, it's quite an incredible creature, right? Remember we said this? Now, to help clarify the application of this approach to biology, we'll consider some examples of how design traits contribute to successful performance. I'll take you back to Dr. Galuza's article again. When Hurricane Michael blew through Mexico Beach, Florida in October 2018, the homes in entire neighborhoods were flattened. But in one neighborhood, a single home surrounded by devastation was left virtually unscathed. A Fox News headline called it a miracle home. But miraculous explanations aren't needed. The home was engineered with traits, design features, specifically intended to solve the problems associated with hurricane. And this is the house in question.
Good, great.
And look around. Mexico Beach, Florida. This was owned by a Dr. LeBron Lackey. He designed the home to withstand winds of 250 miles an hour. He said, we intended for this to survive. So, we're going to ask the silly, absurd, rhetorical question. Did Dr. Lackey's home survive in October 18 because Hurricane Michael selected for his home and selected against all the others that were destroyed? We'd say, no, that's absurd. Hurricanes don't select anything. They just do their thing, right? Which is spin around and create havoc, okay? It was designed to survive, just like the tardigrade was designed to survive. Here's a picture of results of an earthquake in Kathmandu, Nepal, April 25th, 2015. 9,000 people died in this earthquake. We would not say that the earthquake or nature selected for the building on the right and against the building on the left. Okay? Earthquakes just shake, and the building is either going to be designed to survive or not designed to survive. Okay? So you follow where we're going. We're using engineering examples to get you kind of grounded in this, and then we're going to go into biology and look at how that works. Now, an evolutionist might say it's not fair to compare a biological system to a non-biological system. They'll say, hey, that's like comparing apples to John Deere tractors. Okay, let's give them that for the time being. But let's answer this by looking at biological systems with an engineering perspective to see which one fits better. Going back to Dr. Galuza, engineers usually add a safety factor that enables what they've designed to withstand exposures somewhat outside these parameters. Even so, they know that given an excessive exposure, the entity will eventually fail. Okay? Not every person can afford to have their house built to withstand 250 mile an hour winds. And it really wouldn't be practical here in Heber, Heber, in Payson either. We don't have 250 mile an hour winds. 50 is bad enough. That failure, however, is not indicative of a faulty design. Faulty designs specify features from the outset that are unable to withstand the exposures necessary to meet the design's intended purpose. Like I said, I'm not designed to live at the South Pole. Penguins, they can do that, okay? Thus, even homes that were flattened by Hurricane Michael were not necessarily poorly designed or shoddily constructed. Since they likely withstood prior hurricanes, they probably just were not designed to ever resist one of Michael's force. Okay, so we're understanding that, yeah, given constraints, you can't build something that would be impervious to everything, okay? I mean, even Superman had kryptonite, right? We know engineers don't design things that will have unlimited resources to build them. Even sophisticated designs are expected to operate only within various ranges of different exposures. These ranges are called the design parameters. Okay, so you have parameters, like you have certain limits that you only can go up to just because of size, weight, building materials, cost, whatever. But in the biological world, it works the same way. The same is true for organisms. When one of their appendages or organs breaks because it was exposed to conditions outside its design parameters, it reflects a situation in which design parameters were exceeded rather than a faulty design. Why would anyone think that creatures should have design parameters that could never be exceeded, even if designed by an omniscient creator? So hey, everything has its limits, but the question before us today, as we start to look at these critters, God's awesome critters, is an organism's ability to adapt best explained by modeling clay or awesome design? Modeling clay, awesome design. Now, remember the adjustments. In addition to what we're going to also look at is the fact that these responses that the organism, the output actuator, the response, they are going to be regulated as opposed to random. They will be rapid as opposed to long, slow, and gradual, like Darwin said. They will be repeatable in terms of being predictably consistent. The creatures will do it again each time. And targeted to address the needs of the organism. All right, so we're ready to go into this now. We've got our foundation of engineering laid out. Now let's go look at critters. We'll start with looking at frogs, but not this guy. And this guy, well, he's cute, but not the right guy either. Okay. Not sure what to make of this one here. What I had in mind really was this. Now, isn't this cute, right? This is a wood frog. The wood frog has two scientific names, which I won't attempt to do right now. The only frog discovered living north of the Arctic Circle. In the winter, the wood frog goes into extreme hibernation. To prevent cellular destruction from freezing, the frog goes on a sugar high by manufacturing high levels of glucose in its body. The glucose lowers the freezing point of the frog and provides enough energy to keep the cells alive. Okay, so it manufactures high levels of glucose, just enough to keep it from freezing and to maintain its metabolism. If it did too much sugar or not enough sugar, then the glucose also inhibits metabolic reactions like urea production from taking place. High glucose levels would normally kill the frog. Except, what's really cool is that this glucose spike only occurs just before the frog freezes. How does that happen? When ice crystals first start to form on the frog's skin, a message travels to the frog's liver to convert much of its stored glycogen into glucose. 5 minutes after the signal is received, the sugar levels in the frog's blood begin to increase. During this period, the heart stops beating and the lungs quit functioning. It takes about a day for the wood frog to thaw, starting from the inside and moving outwards. The signals that stimulate the heart to start beating again and the lungs to start working are unknown. Okay? They know how it goes into this state. They're not sure how it pulls itself back out. Does it have a timer built in? Or when it's in this state, does it still have sensors that says, okay, it's spring now? So, what do we have? We have input sensors to detect ice on the frog's skin. We have internal programming to determine that it needs to engage the output actuators to trigger the cascade of processes to flood the frog with glucose. So, what was Charlie's theory? Numerous, successive, slight modifications. No. And these responses are regulated, they're rapid, they're repeatable, and they're targeted. Here's another little ugly creature. This guy is called the Arctic Springtail. Scientific name is Onechirius arcticus, okay? Looks like an insect, but it's actually an arthropod because I have his legs. Average size is 2/10 of an inch long. They spend the spring and summer in the mossy areas of the Arctic. When the temperature drops to a certain point, the springtail begins shedding its internal water in a process known as cryoprotective dehydration. In the spring, the springtail rehydrates itself and goes about its business. So here's what it looks like when it's fully hydrated. And when it's dehydrated, it kind of just shrivels up like that. Now, how does continuous environmental tracking explain this? Input sensors to detect the colder climate conditions. Internal programming to distinguish a sudden cold snap from winter's actual onset. You don't want to have this process start when it was just a short little, flash in the pan type of thing. And then it has to have output actuators to activate the cryoprotective dehydration sequence in its body. And because it's all dehydrated and dormant, researchers still don't know how it comes back out on the other side, okay? Either it has input sensors to detect the warmer climate and internal programming to distinguish the sudden warm spell from a flash early just warm day, and output actuators to begin the hydro reabsorption from atmospheric humidity. Or it may have an internal programming, a clock that goes off at the appropriate time when the weather conditions are suitable for rehydration. And this is a small, dehydrated, lifeless little bug. Now, this sounds cliche, but that's cool. Compare that to Darwin, numerous, successive, slight modifications. Doesn't look like it. What I see is regulated, rapid, repeatable, and targeted. Okay. Let's take a look at cornfield. How on earth does corn employ continuous environmental tracking? I said critters, but I was careful to say organisms, right? How does corn employ environmental tracking? Some cornfields get invaded by caterpillars. A caterpillar invades a cornfield and begins munching on a particular corn plant in the field. The corn plant begins releasing volatile chemical compounds, which we know as pheromones, that are sensed by the other nearby corn plants in the field. The other corn plants begin to produce a different volatile compound that attracts parasitoid wasps to the cornfield. Parasitic, but not totally, because it's the wasps themselves aren't the predator. The wasps instead lay their eggs on the caterpillar's skin, and the eggs do the dirty work, right? The eggs hatch, and the wasp larvae eat the caterpillar. Now, we also need to keep in mind, the corn plant does not respond to routine damage by leaves, wind or hail or something like that. The corn plant's defense is triggered by the presence of caterpillar saliva. The compounds that attract the wasp do not have any effect on the ears of the corn. You wouldn't want to have this chemicals floating around that are going to make the corn unsuitable to eat or anything like that, right? Pre-designed organic pest control. And what are the three components? Input sensors to detect caterpillar saliva, internal programming to recognize the threat as being distinct from routine damage from wind or hail, and output actuators to release the volatile compounds. And that's just for the plant that's being attacked. The other plants in the cornfield have to have input sensors to detect the volatile compounds. They have to have internal programming to recognize the compounds are signaling an attack by caterpillars. And then they have to have output actuators to release their volatile compounds to attract the wasps. Amazing. And the falsification test, numerous, excessive, slight, or regulated, rapid, repeatable, and targeted. Well, that's just the corn plant. There's one more component here. What about the wasps themselves? They have to have input sensors to detect the volatile compounds, internal programming to recognize the compounds and the direction from which they're coming, and output actuators to direct the wasps to the affected cornfield to lay their eggs. A 3-stage organic pest control system. But it just happened. And numerous, excessive, slight, or regulated, rapid, repeatable, targeted. What about flowers? This is an evening primrose, and they react to honeybees. Dr. Gazelle recently gave a talk on bees and honey, and he mentioned some of this. So I did a little more work, and I found an October 2019 article from Creation Magazine by Dr. David Catchpool called Hear Bee Make Nectar. Not only can plants hear, but they can rapidly respond to certain sounds. New research has shown when a recording of the sound of a bee buzzing nearby was played back to an evening primrose flowers, they began producing sweeter nectar. Within only 3 minutes from first sound exposure, which is the time researchers had to wait to collect the quantity of new nectar required for their measuring equipment, the concentration of sugar in the nectar increased by approximately 20% on average. Bees can discern concentration differences as small as 1 to 3%. So even allowing for old nectar diluting the newer product, it would still be a significant incentive for bees to more regularly visit flowers of that species and to stay longer when they do, increasing the chances of their pollination. The researchers found that the sound of buzzing bees caused the flowers to vibrate. This suggests a key role of the flower, particularly the petals, in directly receiving or at least enhancing reception of the bee's sound. The flower functions as an ear, say the researchers. The point of all this? As the researchers explained, producing high-grade nectar all the time would use a lot of the plant's resources, and exposed nectar is subject to degradation by microbes. So, a mechanism for timing the production of enhanced reward for the bees to a time when pollinators are likely to be present could be highly beneficial for the plant. Indeed, a win-win for both species. So, a temporary boost in sugar content can last up to 6 minutes, and pollinators were more than 9 times more likely to visit a plant like that had been visited by a pollinator within that time frame. So the author of this study concludes by saying this. Of course, the researchers attribute this to evolution, but describing an organism's hitherto unrealized feature and its usefulness is not the same as explaining its origin. Rather, who'd have ever thought of a flower being akin to an ear? Answer: the one the Bible says made the flowers and the bees and everything else in this mind-bogglingly complex creation that continues to surprise and delight. You can find that online at creation.com, here-be-make-nectar. So flowers need input sensors to detect bees' wings vibrations. They need internal programming to recognize the vibrations as being within the frequencies relative to pollinators. You can't just go out there with a tuning fork and start hitting random notes and having it happen. It has to be certain frequencies. And output actuators to initiate the process of increased nectar production. Compare that to that or that. Regulated, rapid, repeatable, targeted. While we're on the subject of plants, I found another article from this version of Creation magazine, January 2019. Dr. David Catchpole, again writing. He happens to be a plant physiologist, by the way. He wrote an article called Plants Are Listening. A news release from the University of Western Australia announced that plants have far more complex and developed senses than we thought, with the ability to detect and respond to sounds. In particular, fascinating research has shown that seedling roots can hear the sound of gurgling water. Researchers grew pea seedlings in pots shaped like an upside-down Y, such that the roots had a two-way choice. They grew towards wet soil rather than dry soil, that makes sense, or aimed for a tray of water instead of the dry soil. Remarkably, when one of the choices was a sealed pipe through which water flowed, seedling roots grew towards it rather than dry soil. So here's kind of a picture of what that looked like. You got the plant, you got this Y-shaped pot, you got soil here, soil there. It's the same moisture content, but when water was flowing through the pipe, the roots would almost overwhelmingly go down the side with the pipe. They just knew the water was there, even if the only thing to detect was the sound of it flowing inside the pipe, explained lead researcher Monica Gagliano. No relation. Not even close. And in the instance of wet soil being offered as an alternative, the plant roots grew towards it rather than the gurgling pipe, which makes sense. It has moisture detectors, prompting the researcher to surmise that plants use sound waves to detect water at a distance, but home in on actual moisture when it is nearer. Dr. Gagliano explained the research indicates that the invasion of sewer pipes by tree roots may be based on the plants hearing water and shows that their perception of their surroundings is much greater and far more complex than we previously thought. And probably all of us at some point know of somebody who at some point had a sewer pipe that got clogged by that. Where did such impressive hearing ability come from? According to Dr. Gagliano and her co-workers, it is apparently attributable to evolution. But the staggering complexity of plants with these incredible sensory capacities, only now being uncovered by scientists after years of painstaking research, speaks powerfully of having been designed on day 3 of Creation Week. The Bible identifies this designer as our Creator, Lord, and Savior, Jesus Christ. All right, folks, they're not just detecting moisture, which we would expect them to do. They're detecting the vibrations of water flowing somewhere underground. Input sensors to detect vibrations of moving water, internal programming to recognize the frequency and related sounds as being produced by water, and output actuators to direct root development in the direction of the underground water source. Numerous excessive slight. Regulated, rapid, repeatable, targeted. Mighty Casey strikes out again. Let me introduce you to this critter. He is the bluehead wrasse fish. Scientific name is Thessaloma bifasciatum. They live in and around the Caribbean. Unlike most fish, they swim mainly with their pectoral fins. They are a popular addition to saltwater aquariums. The larvae bury themselves in the sand until they emerge as juveniles. They are very bold and may approach humans in the water. And this is how they live. One male with a harem of several other females. For want of a better term, we'll just say a harem. You can call them concubines if you'd like, okay? Now, while that may seem very interesting to teenage boys, right? It's not such a good idea because you see the male is bigger and more colorful. That makes him a more tempting target for predators. So what happens if the male bluehead wrasse is taken from the harem? A female from the harem will transform into a male. Now, in our current culture today, there's a lot of talk about sexual identity, and we have hormone therapies and gender reassignment surgeries and things like this. Human genders are determined by chromosomes, XX or XY. Sorry, folks, it's binary. Not so with these critters. The adaptation is achieved by means of epigenetics, where you have markers that are being placed on, like tags, on portions of the DNA. They will activate some portions or deactivate some other portions. So it's different. But then again, we're not males living around with harems and subject to predators, right? So if God wants fish to survive, he's got to make them the ability to adapt so they can survive. Within minutes of the male's absence, the largest female in the group will begin the transformation process. So somehow, in that sensory thing, it goes to the largest female. Within 10 days, the ovaries have shriveled and testes are fully functional. Within 20 days, all anatomical features, colorations, marking, etc. of the male are complete. And this is only one species of fish. Research have identified more than 500 fish species that regularly change sex as adults. Clownfish begin life as males, then change into females. And Cobudi do the opposite. Some species, including gobies, can change sex back and forth. The transformation may be triggered by age, size, or social status. And you don't have to take my word for it. This comes from theconversation.com, where we learned from a fish that can change sex in just 10 days. Input sensors to detect the absence of the male. Internal programming to recognize the input as requiring activation of the epigenetic sequence, and output actuators to initiate and regulate the gender transformation process. Amazing. No hormone therapies, no gender reassignment surgeries. It all happens. And does it happen by this, or does it happen by that? Okay. What about, I'm looking at the clock here, I think I said this. From the movie Robots. No, not Ricola. We're going to talk about E. coli, this bacteria, E. coli, right? Now, this is amazing. For no other reason than the fact that E. coli is a one-celled organism. It has no brain, right? They live mostly inside our gut. Now, where you say, well, wait, E. coli, isn't that kind of a bad thing? Well, certain strains of E. coli have mutated and become pathogenic. There's a few bad characters out there. But those are the ones that mutated. Now, a lot of the information from this comes from this recent article from the January, February, March of 2022, this year, Creation Magazine. This is the cover. It's also available in digital. You can subscribe to creation.com, look for the magazine and subscribe. This is the article right here talking about E. coli's electric motor, a marvel of design. Now, the credit for this article goes to a guy he's writing under the name David Thomas. It's a pen name because he's currently studying biological science at a university, and he doesn't want to have his name associated, and the university won't, and they would probably rip his scholarship and his fellowship and everything out if they knew who this guy actually was. But now E. coli first became popular amongst creationists in 1996 when Michael Behe published his book Darwin's Black Box. And this is where he coined the term irreducible complexity. Did you know that the simple bacterium, this is from the article now in the magazine, E. coli swims through our gut using sophisticated nanoscale electric motors. Each of these motors spins a whip-like flagellum at the super high speed of up to 22,800 RPMs. In 96, it was estimated about 10,000 RPMs. Now they've more than doubled it to 22,800. And some bacteria can actually spin at over 100,000 RPM. The spinning flagellum acts as a propeller. E. coli's motor is about 45 nanometers or billionths of a meter wide. 2,000 could be lined up across the width of a human hair. Evolutionists have called it a remarkable nanomachine, a sophisticated rotary motor, an example of elegance in molecular engineering. These are evolutionists saying this. They're really out on the edge when they say this, right? So here's what they look like. Okay. I'm not going to pause. I'm going to keep going. I haven't got an alert saying I'm almost out of battery. It says that, okay, here's how it works. The protons flow the flagellar motor. They cause it to spin. At the base of the motor is the essential gear surrounded by up to 11 powered gears. In other flagellated bacterial species, as many as 11. The current flowing through the powered gears causes them to rotate, driving a central gear. The powered gears rotate around axles that are anchored to the cell wall. The rotor, which I'll show you in a second, connects to a central gear in the drive shaft, made of an inner ring, outer ring, adapter ring, socket with the drive shaft. Drive shaft passes through the cell through a ring proteins that serve as bushings. The outer surface of the drive shaft and inner surface of the bushings are very smooth, separated by a thin layer of fluid. These optimally designed bushings allow the drive shaft to rotate with very little friction, making the motor almost 100% efficient. That's a marvel of engineering in and of itself. The hook-shaped universal joint has about 20 moving parts. Design makes it very resistant to twisting, flexible to bend. Okay. Gear mechanism. The motor has two gear shifting mechanisms, one to change direction of rotation and one to adjust power output. Direction of rotation and power output. In a one-celled, brainless creature. The motor switches between forward and reverse in less than a millisecond by changing the diameter of the top and central gear. Here's how that works. Okay, so these gears, these are the drive gears, okay? And you see how they all spin in a clockwise direction. If this ring is on the inside, then as these are spinning this way, it forces this ring to go this way. To change direction, all it has to do is enlarge that ring. Now it's on the outside, and these wheels are still turning clockwise, and then so does the main propeller. It's like a two-stage clock. Boom, 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 boom. It's, forward, reverse. Now, if this isn't amazing enough, okay, we don't have transmissions where we can just throw our transmission to reverse. It blow all the gears up. Scientists have yet to analyze exactly how the clutch mechanism works to cause it to go from inside to outside a ring. But watch this. The second gear mechanism performs the same function as gears on a bicycle. If the cell swims into thicker fluid, it becomes harder to rotate the propellers. The motor detects this using torque sensors. One-celled, brainless critter. Torque sensors, and automatically engages more powered gears with the central gear, increasing the rotational force produced by the motor. The opposite occurs if the cell swims into thinner fluid. This sophisticated gear mechanism makes the whole system extremely energy efficient since it doesn't use any more power than needed. Okay? So, it's going along, it decides, oh, it's thicker now. Okay? So what it does is it pulls more of these motors in to give the motor more torque. When it senses that it doesn't need them, it drops them back out, so it's not using any more power than it needs to, because why waste energy needlessly? One-celled critter, okay? This is pretty amazing. Talk about the motor construction here, and I go through all this, and it talks about how it's built. We'll kind of skip that. This is a schematic diagram of what regulates the motor functions. This is how this engineer has basically laid out a schematic diagram. And it talks about ribosomes, protein signals. Each of these little things has a label for the different protein that it works with. So look at this will overwhelm you. You don't have to have this memorized. It's not going to be on the quiz, okay? But I want to jump ahead to input sensors to detect the viscosity, internal programming to determine how many additional power gears are needed for the drive motors, and output actuators to deploy or remove the additional power gears of the drive motors. Now, the thing has to navigate, right? Without a brain, it has to navigate. The amazing motor would be largely useless without a way to steer the cell. The cell navigates its environment using a system that tracks chemical gradients with exquisite precision. And this is what the article says. Navigation system is able to turn the cell by switching the rotation direction of the motor in any of its 5 to 10 flagella. Okay, and we'll go through all this, and it says it's a beautiful architecture. Circuitry includes short-term memory feedback loop compared to different concentrations over time, so it has to keep track of different gradients. That just sounds like a data storage unit in a one-celled critter. Okay. Hexagonal architecture, thousands of binary signals, feedback loops, different sensor types, up to amplifies signals up to 50-fold. These features give the navigation system high sensitivity, huge dynamic range, and an impressive amount of signal amplifications. Yet, E. coli's navigation system is one of the simplest in bacteria. Most are much more complex. Would you like to see a graphic representation of this navigational sensor array? Of course you would. This is what this researcher has basically drawn this out, and it's like, does that look accidental, random, numerous, excessive, slight, or does it look like it was designed to do this? Input sensors to detect the chemical gradients in the surrounding medium, internal programming to determine whether to navigate towards or away from those chemicals, and output actuators to reverse the direction of whichever drive motors will need to get it where it needs to go. Numerous, excessive, slight, rated, rapid, repeatable, targeted. I think we would have to put all this together to say to Mr. Darwin, sorry, Charlie. So we'll wrap this up. The electric motors of many bacterial species are even more complex than the one found in E. coli, with many extra parts, sometimes including a clutch or a brake. Many of the details in this article were only discovered over the last few years. No doubt many more fascinating discoveries will be made in the years to come. Bacteria are far from simple bags of chemicals. The function, control, and construction of E. coli's electric motor shows layers upon layers of sophisticated design and engineering. This motor brings glory to its designer, our Creator, Jesus Christ. Can we all say amen to that? Now, we've emphasized Darwin's falsification test. I want to end by asking this. Does the Bible have a falsification test for God? And my answer is yes and no. It's more of a validation test, and it comes from two verses. The first is found in Jeremiah 29:13. You will seek me and find me when you search for me with all your heart. In Hebrews 11:6. And without faith it is impossible to please God, because whoever comes to God must believe that he exists and that he rewards those who earnestly seeks him. If anyone seeks after God and sincerely wants God to reveal himself to them in their life, God will make himself known. He delights to make himself known. Chapter 7 in Hebrews goes to say, for the law never made anything perfect, but now we have confidence in a better hope through which we draw near to God. And Hebrews 7:25 says, consequently, he is able for all time to save those who draw near to God through him, since he always lives to make intercession for him. I will go so far again as to say that God delights to make himself known to anyone and everyone who seeks after him sincerely. And James 4:8 tells us to draw near to God, and he will draw near to you. This is just one of the many manifold promises of God, and I hope that this presentation this evening inspires all of you to draw near to God. Thank you. It says I still have 2 hours and 40 minutes left. It said an hour and 19 at the beginning, and now it says I have more than double that. It's like, so we're doing it again. I'll tell you what, after the Q&A, I got a short little song I can play. I have it included in here too. So